Advanced related rates. I love related rates. Here we go. Let's see. Okay, we're increasing, and this dude is a rate. Okay, that's d what over dt. What are we going to label it? D what? It says the surface area. What? A surface area? Okay, for surface area, I like to use SA because I know what SA means. It means surface area. Okay, and then it also says the height of the cylinder is 3. Okay, so h equals 3. All right, I don't have to say equals. I just point the arrow. Okay, and then it says at a certain instance, the surface area is that. That's SA. It's not a rate because it doesn't say it's a rate. All right, what are we looking for? We're looking for the rate of change that the volume, so dV over dt. This is what we're looking for. This is the answer, guys. We're looking for dV dt. Okay, so in order to do this, you guys have to know how to find the surface area of a cylinder, and you have to know how to find the volume of a cylinder. Lucky us, they usually give you guys those formulas. They're not going to expect you to remember those. Okay, so right away, what I would do is I would take each of those guys and take your derivative. All right, let's find the rates that relate to each other. So we have 2 pi r to the second power plus 2 pi r h. And I'm going to take the derivative of this with respect to t. So the derivative of surface area is going to be dSA over dt. It's 1 times dSA over dt. And then right here, this is tricky for some people because they see this pi right there. And they're thinking like, oh, do I have to do product rule? You don't have to do product rule. But if you actually did, you'd still get the right answer. But pi is a number. That is not a changing number. So we have 4 pi r. Because I had to drop the 2 and multiply it to the 2. So I have a 4. And then because I'm taking the derivative with respect to t, we have to multiply this by dr dt. That's because of the chain rule, my stews. Okay, next. We have 2 functions of t, that's r and h, multiplying to each other. And we have something cool that's about to happen, actually. So I'm going to treat this one as one function. We have 2 pi r. If I take the derivative of that, I get 2 pi. And then times dr dt. Then plus, now I don't need the parentheses because we're adding this, okay? We're doing the product rule. Plus 2 pi r times the derivative of h. Oh, shoot, I forgot my h. Did anybody see that and not say anything? Oh, why aren't you going to say something?
Because I wanted to...
Yeah, whatever. Yeah, you be quiet. Okay, what is the derivative of h? It's 1. And then I multiply it by dH dt, says the chain rule. All right. So this is actually not what we're looking for. We're not looking for dSA dt. We're looking for dV dt. So I'm going to hold off on looking at that anymore. Let's look at our volume. The volume equals pi r squared h. All right. Pi r squared h. So let's take the derivative of this with respect to t. We get dV dt. Hey, that's what we're looking for. And then we have another product rule here. There's my first function, and there's my second one. So my first one's going to be 2 pi r dr dt. Multiply it by the h. I didn't make a mistake this time. Plus, then we have pi r squared times the derivative of h. The derivative of h is uno. And then we have to multiply it by dH dt. I don't write uno because 1 times anything is, nothing. All right, this is what we're actually looking for, dV dt. So let's see if we have all the variables we need in order to find dV dt. Okay, so let's see. Do we know what r is? Oh, shoot. We hit a roadblock on our first variable. How are we going to find the r? My guess is this. Going back to either this equation, the volume one, or the surface area equation, because both of those have r's in them. And you want to pick the equation that has all the other variables. Now, this one looks big and scary, so I'm going to check this one first. Okay, I don't know r. That's what I'm looking for. Do I know what the volume is? No. Do I know what the h is? Ooh, I know what the h is. But if I don't have my volume, I'm done. I can't do anything. So I can't use this equation. Let's go up to this top one, the big scary one. Do I have the surface area? Oh, I do. That's 36 pi. Do I have the R? No, that's what we're looking for. Do I have the H? Oh, shoot. It looks like we're using the big scary one. Okay. So what was SA? 36 pi. And then we have 2 pi R squared plus 2 pi R. And then I know what my H is. That is 3. Okay. Do I have only one variable that I can solve for? Yes. Sweet. Now we can get busy. Okay, so I'm going to get busy here. I'm going to make this into a 6. And then I'm going to simplify. It looks like I can divide everything by pi. Can I divide the left side and the right side by pi? Yes, and that'll simplify things quite nicely. Is there any other number I can take out of both sides? I can take a 2 out of both sides. That'll make things nicer too. Okay, so let's rewrite what we got. I'm going to come over here and write it. We have 36, divided by 2, which is going to be 18. Pi divided by pi is 1, so that's gone. I have 2 pi r squared divided by 2 pi, so that's going to be r squared. Plus 6 pi r divided by 2 pi, that would be 3 r. And now we got to solve this. Hey, it's a quadratic. Do you guys remember these dudes? I wanted to forget them. No, you can't. Okay, let's hopefully this factors. What multiplies to give me negative 18 adds to give me 3. Negative 3 and 6. Does that work? Let's see. Negative 3 times 6 is negative 18. If I add negative 3 and 6, I do get positive 3. Okay, so we're good. We're sitting pretty. So what are our two answers? Oops, I messed up. Did anybody see my mess up? You did it. Jack, you didn't catch me on that one. R. Okay, so what does R equal? 3 and negative 6. Now, which one of these answers can I eliminate right away? The negative, because we cannot have a negative side in geometry. But now I have an R. Okay, so I can put my R in right here. That's a 3. Do I know what my dr dt is? Dang it! We got stuck again. Now, where do I find a dr dt? I see a dr dt in this, but that's not going to help us because we don't know what dv dt is. And I see a dr dt in this. Okay, hold on. Do we know that dsa dt is? Yes. Okay, what is that? That is 9 pi. Do I have an r? It's 3. Do I have a dr dt? No, that's what we're looking for. Do I have... Nope, don't have that. Do I have an h? What's my h? It's 3. And then do I have an r? Yes. Do I have a d... Ooh, do I have a dh dt? Ooh, this one's hidden, guys. Now, dh dt means that h is changing. Is h changing? Oh, shoot. I totally missed that word. Did you guys see that word? This word right here, it says fixed. The height is fixed. Now, if it's not changing, what's the rate of change? 0. So this is 0, which actually eliminates this whole thing, which is nice. Because anything times 0 is 0. All right. Is the only variable we have right here dr dt? It looks like it is. Oh my goodness. Look at all this junk. We have so much writing to do. Okay, 9 pi equals 3 times 4, which is 12. So I have 12 pi. And then I have dr dt plus 2 pi times 3. Did I just hear, are we supposed to do this? I know, right? Okay, so 2 times 3 is 6 pi, and then dr dt. So I have dr dt here. Now I'm going to take out the dr dt. Okay, guys, what do I get? What is 12 pi and 6 pi? 12 pi, 6 pi. That's 18 pi. So I have 18 pi times dr dt equals 9 pi. So what is dr dt going to equal? That equals 1/2. Yeah, we would divide both sides by 18 pi. The pi's cancel out. 9 over 18 simplifies to 1/2. All right, we got 1/2 for dRdt. Do we know what h is? What is that? It's a 3. Do we know what r is? No, wait. R and h are 3? Oh, that's weird. Okay, so that's 3. Do I know what dH/dt is? Oh, that's 0. It eliminates that. Hey, that's nice. Okay, almost done. Almost done. Oh, the pain. 2 times 1/2, they cancel each other out. It becomes 1. 3 times 3 is 9 times the pi. We get 9 pi. And that's it. Wait, is that right? 9 pi is dV dt. That was disgusting. That was disgusting. That's our answer. And the units are cubic meters per hour. We weren't asked for the units, but there they are. Why is it cubic meters? Why is it cubic? Oh, it's volume. It's cubic, huh? Cubic is the power of 3, so you would write it like this. You would say meters. So meters to the 3rd per what? Hour.